What about it, YouTube? Okay, following up on yesterday's video, we have this claim that there's a drone or a helicopter flying on Mars, and I'm not so sure. I had a guy tried to butter me up a little bit about how I could remember the distance to Mars, which I screwed up actually by a factor of almost 100. Um, the distance to the moon, if you believe what they say, the distance to the moon is 200 some odd thousand, and you get upward of 200 million um, miles to Mars. So that's a long way to take a drone. And let's see, they're testing this. Oh well, a couple more things. That I had to try and consider, and some of it's based off of this too, but it's not my main point. Um, the the spin up, the RPM of the blades, they say that it's 2,277 RPM. When I first tried to look up how fast drone blades spin, uh, I was comparing sort of apples to oranges because, of course, the drones use like a four blade system typically, and they're smaller, and so they have a higher RPM than something the size of what we're about to see here. This thing they're saying is upwards of about a meter total diameter, so you're talking about 16, 17-inch blades. That's pretty close to an RC helicopter. Okay, and when I looked up RC helicopters, they spin anywhere from 1,600 to 3,000 RPM. So we're talking about nothing different than a on-Earth RC helicopter, from what I can tell, as far as the physics of the spinning blades and such, with an atmosphere that is over 100 times less. 0.088 our atmosphere. Uh, I don't know how you can use the same RPM and basic same RC helicopter technology to float around Mars. Now, some people are saying, well, Mars has one-third the gravity. But it's air that gives you lift, not gravity. So there again, uh, it's and it's another question I've got about the simulation. If it's simulating Mars, it should, if it's possible. I don't know how you take away gravity on Earth, but if you're going to try and do it right, you'd want there to be one-third less gravity, and you'd want there to be 0.088 of an atmosphere, a mathematical zero, a near vacuum is what you would want to test your magic helicopter, your integrity helicopter in, right? Drone, whatever it is. So that was my first debunking attempt, was let's look at the RPMs. And I think that's a decent argument. How can they be spinning the same speed roughly and creating the same lift when you don't have the air? But I think I found something even better. And before we get to that, one last thing. The air temperature on Mars fluctuates between negative almost 200, depending on where you're at on Mars, they say. The average temperature is negative 81. Okay, here we go. Mars has an atmosphere that is 100 times thinner than the atmosphere of Earth. As a result, Mars' atmosphere cannot retain heat, and the surface of Mars has an average temperature of negative 81 Fahrenheit. During winter, temperatures at the poles drop even further, reaching lows of 195 negative Fahrenheit. Near the equator of Mars, daytime temperatures during the summer can reach a balmy 70 degrees Fahrenheit, but plummet to 100 degrees Fahrenheit at night. So, something I learned studying strength of materials 30 years ago, and something you may notice if you have a amplifier or receiver that you used to play music on. Now they make your amplifier or receiver where it doesn't completely turn off. It'll go into like a standby mode. And the reason for that is the chips inside of the unit, from heating up and cooling down, heating up and cooling down, it's like taking a piece of metal and going like this. All right, and do you know what happens? Anyone? Eventually it weakens and it snaps and breaks. And that's what's going to happen to your electronics. You can imagine the more extreme the temperature shifts, the more it's like bending it even further. You know, instead of just doing this, because you're staying within like room temperature and however hot your amplifier gets, now you're going down to 100 degrees minus and up 170 degree swing every 24 hours. So I propose that that's going to be a problem to your electronics if you're trying to boogie shoot around Mars in your helicopter. But I think I've really found the key ingredient to call total BS on this crap. And we're gonna witness it here with this video that that was linked to me. Okay, and again it'll show the RPMs, and what we're about to see reveals something. But I'm going to give you a big hint. It isn't necessarily what we're about to see. It's what we're about to hear. Okay, here we go. Notice the wind. It's a pretty good sized wind in a .088 atmosphere. Just make sure we... So they've already got it on, 3 years later, they've got it 200 million miles away. Spin up, 2277. Sorry I'm having to talk so loud in this vacuum. Okay, so that's all I really needed to show you. It's amazing that NASA has built a remote control helicopter. This one needs a wire to it, by the way, which is interesting. But congratulations, NASA, that you've built a remote control helicopter that operates basically no different than any other RC helicopter that you can find on the market. Spin up, 2277. And the key ingredient, if you missed it, this was the whole key to this video. If you're in a vacuum, sound travels through air. Sound waves must have a medium to travel through. By the way, the reason why light can travel through a vacuum is because of the ether. Okay? but the way sound travels is through air. So if this was really a replication of the Mars surface with a 0.088 atmosphere, you would have a 99.12 less dB, decibels. Right? Is that, I think so. I think I've got that right. It certainly shouldn't be so dang loud that I can hardly talk over it. Seriously? What we just saw is a joke. A total joke. The integrity of the integrity, it's basically as thin as Mars' atmosphere. So that's it for this one. I'm still calling total BS on this boogie shooting around with drones on Mars. All right, that's it. God bless.